Hello once again, Physical Science 9 students from Duluth Public Schools, back for another tutorial on your distance learning topics. Week 3 has you learning a little bit more about energy. And if anybody who knows me knows that energy is a subject close to my heart. So, be happy to talk to you about it and give you some of the details that go along with what you need to know as you receive your packet, if you're getting in the packet, or as you receive your online learning from Google Classroom. So, stick around, enjoy the tutorial, and we'll start with the two energy groups. Okay, so let's start with, like I said, the two energy groups. This is going to be different than the energy forms. There's a couple different ways that you can categorize energy. We're going to categorize it into two groups. The first group is called potential energy, and the second group is called kinetic energy. And just from the names, you might have an idea of what's in the group, or at least how the group works. For example, let's start with potential energy. Potential energy is an energy source that has the potential to do work. No work yet is being done. The energy is not being put to use to move something using a force across a distance, which is what we know as work. So potential energy sources are sources that have the potential to do work. Kinetic energy sources are the ones that actually do the work, because kinetic means motion, and kinetic energy is the energy of motion. So the four types of potential energy that we're going to look at are: 1 is chemical, 2 is stored mechanical, 3 is nuclear, and 4 is gravitational. So let's take a look at 4 forms of energy that fall under the potential energy group. The first one we're going to talk about is chemical energy. And chemical energy is stored energy in a chemical form. The most common that you run into every day is going to be good old-fashioned food. In your food is energy that you will eat, put into your stomach, and then your body's metabolism extracts the energy, and then that allows you to do movement with your muscles. It comes from the food that you eat and the energy stored in the chemistry, in the molecules of the food that you consume. Another example of chemical stored energy would be a battery. Batteries have chemicals on the inside of them that are kept apart a little bit. And when you connect this side to this side, that energy will flow from one side to the other. It's that flow of energy that we use. But in the meantime, it stays stored in chemical form inside a battery. All right, our next type of potential energy is mechanical stored energy. And what does that look like, you say? Here's a Nerf gun. In this Nerf gun, if you were to open it up and look inside, would be a spring. When I pull this back right here, that spring is now in a position that is stored energy in it. I pulled it back and it stored that energy pulling back, and all I got to do is pull the trigger. There we go. And that energy goes from stored mechanical energy, like stored energy of motion, into actual motion energy. And that's what propelled the little dart. I hate to use another example of a hunting device or a weapon, but this is a really obvious example of stored mechanical energy, stored energy of motion. I pull back on the string, and now that motion is stored back here and will be released when I let go of the string, like that. And of course, if there were an arrow in there, it would propel that arrow, turning the potential of it being pulled back into kinetic of the motion of the arrow. The third type of potential energy is nuclear energy, the energy that's held in the nucleus of an atom. Where would an example of that be in your home? Right here. In your smoke detector, there's a small amount of an element called americium. Americium is slightly radioactive, though not harmful to you. It releases a particle that ionizes some air, and then there's a flow of ions. If that flow of ions is interrupted by smoke, the smoke detector goes off. That americium has the potential throughout the life of the smoke detector to release particles. So it's stored in the nucleus and gets used little by little as the life of the smoke detector goes on. Our last type of potential energy is gravitational potential energy. What does that mean? That means that gravity is going to do the work when the time comes, but in the meantime, an object is placed by its position in a location where it will eventually do the work. One example of this would be the concept of lifting up an object really high, and as it sits up high, it now has the potential to do work. And if my lab assistant would come over here, I will show you that she recognizes the gravitational potential energy here and knows that if I were to drop it, it would do work on her skull and that would hurt.
Oh my God.
But of course I wouldn't do that to her. Another example of gravitational potential energy is that of water above a dam with the potential to do work as it flows through a turbine to below the dam. It's an energy of position. So the water, when it's above the dam, has potential to do the work, but won't do the work until it's flowing through the turbine. So this water, perched high on this table here, ultimately, if I open up the cap, will find its way down to the counter. So it has energy of position right now. Not moving yet, but when I open the cap, let's see what happens. And there you go. Energy of position. So the next group we're going to look at now is kinetic energy. Kinetic energy is the energy of motion. And there are 5 types that we're going to take a look at. 5 forms that fall under that particular group, kinetic energy. The first form is electricity. The second form is radiant energy or light energy. The third form is heat. The fourth form is motion. And the fifth form is sound energy. The first type of kinetic energy, energy of motion, is that of electrical energy. And you don't commonly get to see the electricity, but in the plasma ball, you do. You can actually see filaments of electrical energy flying around inside that plasma ball. Again, you usually see the results of the electricity, not the actual electricity itself. But that's electrical energy, and it's the energy of the motion of electrons. Now, if you move me over here, you can see the results of electrical energy when I click on this light. You know there's electricity flowing. You can't see the electricity, but you can see it doing the work of making the light light up. Kinetic energy type number 2 is radiant energy, also known as electromagnetic energy, or more commonly light energy. Now, there are lights on all over the place in this room right now, so that's really obvious. But there's also electromagnetic radiation between my wireless lapel mic here and the receiver that's on the camera. There's a little signal being sent by way of radiant energy from here back to the camera. And in the case of this stove, if I were to turn on this burner right here, you will see light coming out of there. And I think you also know that there might be a little bit of heat coming out of there as well. Which brings us to the third type of kinetic energy, and that is the energy we call heat, sometimes known as infrared energy. We call it heat, and this particular light bulb inside this little fixture here is a heat bulb. It produces more heat than it does light. Well, I don't know if you can quantify those, but produces a lot of heat. And that heat then is meant to melt this wax, which has some fragrance in it. When that melts, it makes the room smell nice. So the heat is coming off of that bulb and going to melt that, and that's heat energy. So heat energy is an energy of motion. And maybe you're thinking, well, how is it, what's moving? The molecules are moving. The faster the molecules are moving, the hotter the substance is. The more movement, the more energy of those molecules, and the higher the temperature. Number 4 is the energy of motion. And this one is a really obvious one. As I throw this to my lab assistant, I'm going to impart a force on it, and it then will move through space, and she will catch it.
With one hand.
And she'll throw it back. And it has energy of motion. Energy of motion can do work. A hammer is a great example of that. You get the head of the hammer moving, and it will drive a nail. Many, many other circumstances where something that is moving fast is doing work for you. So the last one is sound energy. And sound energy, I think, is pretty obvious to most of us. You are hearing my voice right now because I am making a sound. It's going into the microphone and into the camera. Sound energy is often considered wasted energy because it's not really useful to do any work. Sometimes it's just extra energy. For example, when you hammer a nail, the sound is really not doing any work. In fact, it's wasted energy. You hear it in your ears, but it's not helping drive the nail. So I guess the main example that I can think of off the top of my head where sound is doing work is when you're speaking. Okay, now we're going to talk about how energy changes from one form to another. And this is a fascinating topic because it happens way more often than you have ever thought of it. And we'll start with this example. I am speaking. That is sound energy, is going into this microphone, which is converting it to electrical energy. That electrical energy goes through this wire into this transmitter, which turns it into light energy, electromagnetic radiant energy, which travels through space into the receiver on the camera, which turns it back into electrical energy and brings it into the camera where it is stored on a flash memory. That flash memory card, SD card, actually takes that electricity and turns it into chemical energy as the silicon dioxide and the carbon atoms that flow inside that little gate, it's called, store that information. So that information that is stored in that SD card then goes from chemical back into electricity. That electricity goes into my computer, turns it into chemical energy again. I edit the video, and then I send it to YouTube, who publishes it. And when they publish it, it travels through space, perhaps into your home by way of wireless internet, and into your router, through space radiantly, again, into your computer, a bunch of electrical and some chemical stuff again, and then it turns back into sound and light as it comes out of your screen as you see and hear me. An incredible pathway with, 10 or so, if not more, different energy changes just to get my voice and my image to you. So if you look carefully at most energy sources, you will see that there's a conversion that takes place. The electrical energy that's flowing into that camera is turning into light energy that's lighting up a light. The electrical energy that's flowing into the bulbs in this room are turning into light and heat. The heat energy that comes out of my stove turns into mechanical energy as water boils. I can recharge batteries and I can discharge batteries with chemical going into electric and electric going into chemical. There's all sorts of different chemical changes, and if you look carefully at a system, you should be able to identify them now that you know the two groups and the different forms of energy. So the next thing I want to tell you about energy, I think, is extraordinary. There's a law called the law of conservation of energy, which says that energy can't be created nor can it be destroyed. It can only be converted. Well, if that's the law, then that begs the question, where does energy come from? What was its original source? Well, the answer is amazing. So let's just take our little interaction here and try to trace where the energy came from. I'm creating this video in my living room. They're in my kitchen. And for me to do that, I have to speak and hold myself upright. So where did I get the energy to speak? Well, the energy that I am using to speak comes from the vibration of my vocal cords, that mechanical energy. So where did the vibration come from? It came from me blowing air through out of my lungs into the open air, which vibrates those cords. So where did I get the energy to blow the air? Well, it came from my diaphragm muscle. So where did the muscle get the energy? That came from the food I ate, maybe this morning, raisin bran with milk. So where did the milk come from? It came from a cow. That cow, where did it get its energy? Well, a cow eats grass. Where does the grass get its energy from? Well, grass grows because of photosynthesis and the capture of energy that comes from the sun. And where does the sun get its energy? Well, it's from the stored nuclear power that's in atoms that are in the core of that are undergoing fusion. So almost all of the energy that we experience here on Earth originates in the sun, which begs just the one more question, and that is, where does the energy from the sun come from? And that takes us back to the very, very beginning in the Big Bang. So one of the things that I do as kind of a science nerd is I try to trace the source of a particular action back to where it came from energy-wise. So today I drove to school to pick up the packets that many of you finished. Well, where did the energy come from to get my car from my home to school? Well, it came from the gasoline that was in the tank. So where did the gasoline come from? It came from the oil that was pumped out of the ground. Where did the oil come from? Oil is a fossil fuel. Dead plants and animals is its source. Where are the dead plants and animals? Where did they get their energy? Well, if it's an animal, it's because it either ate other animals or it ate plants. And if it's a plant, those plants got their energy from the sun by way of photosynthesis. So it all goes back to the sun and then ultimately goes back to the Big Bang. Now maybe you heard me say that almost all energy on Earth comes from the sun. Now that's true. Some of it comes from nuclear reactions that take place inside the Earth. Why do we have a molten core? Because of radioactive decay inside the Earth. Which brings us back to atoms, which brings us back to the Big Bang. And that's the source of all energy. All right, I want to thank you again for watching. If you have requests about a particular topic that you're struggling with, you can email me at my Duluth Teachers email address. I'm sure you can find it. And if you learned something, great. If you didn't, sorry, I tried. Tell your friends. Might help them do some of their assignments in week 3 of distance learning. See you next time.